This is the Divimath Dual-Band Analog VTX. And you might be saying, analog? I thought you made digital video equipment. Well, a lot of our customers use analog, and taking a look at the options on the market, I decided there's some things that we could do better and some things that we could do unique, unlike anyone else. So let's open this up and take a look at all the features and see if it's a good fit for you. So this video transmitter is priced at $69.99. And it has an output power of 4 watts. It also has dual outputs. You might be wondering what that's about. One output is going to be 5.8 gigahertz up to 4 watts, and the other output is 3.3 gigahertz up to 4 watts. Now, how is 3.3 useful? That's going to depend on your use case and your environment. If you're flying in a lot of areas with a lot of Wi-Fi interference on 5.8 or 2.4, this completely will avoid that being on the 3.3 band. Now with 3.3, you will have to have a ham operator license in the United States, and in the manual we completely cover all the things that you need to know for what frequencies are allowed for 3.3. This is a useful VTX for freestyle and bandos and long range, anything where having high power output and nice consistent calibrated output is going to be helpful. So if you're flying long range, the 4 watt output is going to be really helpful. We've tested that out to 30 kilometers, verified, both on 5.8 and 3.3. And if you're going to be doing kind of flying in an urban environment, like a bando or whatever that might be, the 3.3 in some cases is going to do better than the 5.8 just due to the physics of that being a lower frequency. This product is NDAA compliant if that is useful to you, but we're not going to cover too much of that. Now let's talk about a little bit of a backstory on kind of the architecture of this analog VTX, because this VTX is unlike any other one out there currently. We have a unique proprietary architecture where we're not using the commonly used rich wave chip for the analog video. If you don't know already, rich wave is the chip maker behind what most analog video transmitters and receivers use. They make a very good chip. Unfortunately, that chip has been increasing in price a lot. So we've actually developed our own architecture that completely does not rely on rich wave and gives us some unique advantages, like being able to change frequencies very quickly and support a wide range of frequencies, 3.3 being one of the examples. The other thing that's unique in our architecture is we have an intelligent auto adjustment for the calibration based on temperature. So as the temperature of this video transmitter changes, we will automatically, dynamically tune to give you the correct frequency output and the correct power output, no matter what the temp might be. If you're installing this into a build where there's not a lot of airflow, you can also purchase an optional heat sink and fan that can bolt on top. Here's an example of what it looks like having the fan. The fan plugs into the side of the video transmitter and it is self-powered by the video transmitter. In addition to the fan that I've shown here, you can also put on our heatsink, and I'll show a picture of what that looks like. The supported power output levels are 25 milliwatt, 250, 400, and then with an unlock procedure that you can perform, given that you have authorization to do this, you can go up to 1 watt and then 4 watt. A note for you though on that, in the United States, telecommando of an aircraft caps the maximum power output on an aircraft to 1 watt of power. So if you use this on an aircraft and you don't have explicit authorization to go beyond that 1 watt, please do not. Now, if you were to use this on a ground vehicle or something else like that, there's no problem as long as you have a ham license going up to that full 4 watts of power. So here's what the product looks like installed inside of a drone. It doesn't occupy up a lot of space. That's the same form factor as a very popular VTX that I won't name. So this is a drop-in upgrade if you have one of those video transmitters that's similar form factor to this. The way you mount it is the included die-cut VHP tape. You put the copper side down and tape it to the frame, and that is designed to conduct heat away from the video transmitter and into the frame for best cooling. You can also then get extra cooling with that optional cooling kit if you want. The cooling kit is not required to get maximum power output. Even a small amount of wind will be able to keep this cool in flight. So I want to point out, you can use this video transmitter just as a 5.8 transmitter or just as a 3.3 transmitter. You don't actually have to use both bands. It's a great 5.8 gigahertz transmitter if you want to use it just for that. Now, here's what it's going to look like if you do go with both of the bands. You're going to have a dedicated 5.8 antenna and a dedicated 3.3 antenna. So these are nice True RC antennas. This is the True RC Singularity 3.3, and then this is the True RC, I believe, Core antenna. These are the ones that I'd recommend that you get also, as they're very good VSWR. You do need to be very careful the quality of the antenna that you use when you have a very high power video transmitter, as having a antenna that's not tuned for certain frequencies will reflect power back into the power amplifier and burn it out. So in the manual, we list requirements for VSWR. You want to take a look at the bandwidth of your antennas that you're using if you're going to be going up to those higher power output levels. Now on the video receiving side, again, if you're going to use this as just a 5.8 gigahertz video transmitter, then you just need one antenna, just this 5.8 antenna. If you're going to go for 3.3, then you'll need a 3.3 VRX like the one I have installed here. This also has that 3.3 True RC Singularity antenna, and with this setup, you can do both 5.8 and 3.3, and you can pick ahead of time before you fly whether you want one or the other. So a unique feature of the Divimath goggle is that you can hop between frequency bands in a split second. I'll cover that in a different video, as that's kind of useful to certain people more than others. So when you're pushing long range, you're going to want to use a directional antenna. And with 3.3 gigahertz being a larger wavelength than 5.8, that also means that the antennas are bigger. So here is a 5.8 gigahertz True RC X2 Air, and this is the 3.3 gigahertz X Air. Quite a bit difference in size, and that just comes down to the difference in the physics of it. So just kind of keep that in mind. You're going to need to plan on having a bigger antenna for the 3.3 stuff versus 5.8. So I'm going to do a little flight test to show you how it performs on 5.8 and 3.3, and then you can kind of see how the two look. So this is 5.8 gigahertz, and as I go behind obstacles, it looks pretty good, but it could be better. And one of the things I think you'll notice when we switch over to 3.3 is behind certain types of obstacles, the 3.3 seems to kind of have no problem or seem to bend through it somehow. And that's because of that lower frequency band than 5.8. The wavelength is bigger, and therefore it is able to kind of move around obstacles. It's not all perfect. You'll see that the 5.8 is actually very good, and kind of on net, they're very similar. Okay, so I'm going to switch over to the 3.3 now. And now I'm looking at the 3.3 receiver on the same drone, and I can kind of poke behind things, and you'll see it is not as much interference for some reason. And it's because of that lower frequency. So I'll pop over here and we'll kind of look at the terrain that we went through before on the way here. And you can just see the breakup is there, but it's different. It's not the same. That's what you'll get with 3.3. It is a different frequency. It's a different tool for different kinds of jobs that you might have. And just remember that you do need to have a ham operator license in order to use this VTX and especially this frequency band. And that is all up to you, whether you have it or don't have it. So we'll pop behind this foliage here on 3.3 gigahertz. And we'll pop again, kind of go down low here and go through. And that's what it looks like on 3.3. We'll repeat the same process here on 5.8. So I'll go ahead and reset. Okay, and then I'll switch the video transmitter to 5.8. So there's 5.8 now. And we'll kind of do that same pass. And you can see they're pretty similar. Now let's go and push it a little bit further than before. We'll head over here. And now we're behind a bigger obstacle, and I'll transition us over to the 3.3. And you can see that there is breakup, but it's a little bit different looking, again, because of that slightly different frequency. So not a decisive or conclusive test by any means, but it does show the difference in how signals behave between 5.8 and 3.3 gigahertz. So there's a lot of details that go into making a good VTX, and one of those details is what happens when the VTX starts to overheat. Well, we've put a lot of thought into this to make sure that your VTX is protected when it overheats. It's going to ramp down its power output until it gets to a level where it is operating at a safe temp. If it goes over 105C, it'll just shut down. It's not like some analog video transmitters where if it gets hot, it just starts to fuzz out and then the power amplifier eventually burns out. This has robust protections in it to make sure that your investment here, it's not that expensive, but this thing is not going to just nuke itself the first time that you crash and have to go recover it out in the field. And it takes 10 or 15 minutes to get to it. I might have done that actually on the one that we were just testing today. Turns out it was just fine, just as we designed it to. It was sitting out in the field for 15 minutes and tested the power output before and after, and it checks out just the same. So you can be confident that while this is outputting at 4 watt, if it does start to overheat, we ramp that power down and protect the video transmitter so that it doesn't burn itself out. Here we have up close the analog video transmitter, and you can see the main plug-in is recessed, which is nice. It protects it from crashes. And then you have direct solder pads here also for all of the pins on that connector, making it really robust. And then on the side here, we have the dual MMCX outputs. One is going to be labeled star and one is labeled 5.8 gigahertz. The star is 3.3 gigahertz mode. In the box, you're going to get a couple of accessories. So here you have a high quality MMCX to SMA adapter. I recommend that you use this one. It has low loss, which is very important if you want to get that maximum power output. There are 2 of those in the box for the dual outputs. Then of course you have the cable here. This is going to be your wire harness. It's 100 millimeters long, connects to the camera and then the flight controller. And remember, you can always direct solder with those nice convenient direct solder pads. Lastly, you have a nice piece of die cut VHB tape. This is used for mounting the video transmitter, and we recommend that you mount it like this so that it conducts heat into the frame and then passively cools this without an additional heatsink. If you do want that additional heatsink, you can go ahead and do that and purchase the optional heatsink and fan assembly.